Okay students, in this part of video we are going to learn more about the distance and as well as the displacement by using the position vector. Here you will recall back your memories about what is the position vector is. Okay, first of all you understand how to represent a position vector. Okay, let's say a person is standing here is a person and observe that a particle is lying here. We have to draw the position vector. It can be done very easily. Select any coordinate axis system. Here I am taking the rectangular coordinate axis system. As you know that it is the x-axis and it is the y, and the axis which is out of the plane is z-axis. Okay, the particle is P is lying there. We have to find out the position vector, and considering this observer as O, that means origin, and you have to draw a straight line from origin to that particle. Here I am drawing a straight line which is drawn, and this is the position vector of the particle. Okay, here taking a point of reference, we are observing the motion of the particle. If you connect the origin and as well as the position of the body by a straight line, we get a position vector. If it is the position vector, it must have the coordinates, isn't it? Say the coordinates are x comma y and z with respect to the three axes which are rectangular. Then this one OP is the position vector, OP bar. I am representing it as R bar. R bar is the position vector. Okay, let's say this particle started from here. It is the initial position. You say it is P1. Automatically it could be x1, y1 and z1. Let's this particle started moving from A and managed to reach the position P2. Okay, here is the path traced by this particle. Okay, now I am joining this position, this point, to the origin. Okay, has been drawn. I am representing it as the position vector R2. Okay, that means it is OP1. You can write it as R1, and similarly OP2 is equal to R2. These are the position vectors of the particle with respect of time. If you consider, or if you put a time, that means a watch there or the clock there, the clock will measure the time of travel of the particle from one place to another, from P1 to P2. Now see what I am doing. I am joining the 2 points. The two have been added in this way. I join. Okay, if you watch it carefully, it is the initial position of the particle and it is the final position of the particle. If you watch it keenly, you will observe it is the path of the particle along a straight line. I think you are understanding now what I am trying to tell. Is a path of the particle along the straight line, and this one, see, the curved path. It is the actual path of the particle, okay, which moved from P1 to P2. Understanding me? It is the path P1 to P2 along the straight line. We have one path, and as well as The actual path of the particle is along this curl line, that is from P1 to P2 only. If you understand these two, you can understand the displacement of the particle and as well as the distance. First, I am naming it as P1 to P2. Here I said it is delta R. Okay, it is delta R. Now listen my words carefully. Okay, we need to find the displacement. We need to find the displacement. Okay, what is the displacement here? You learn that displacement is shortest measured length between the 2 points. Obviously, the shortest measured length between the 2 points is this one, a straight line. I represented it as delta R. Okay, it is the shortest measured length between the 2 points. But here, using all this data, okay, I am finding the magnitude of the displacement as well as the displacement vector with respect to position. Okay, simply you can say displacement as change in position of a particle. Okay, change in position vector of a particle. Change in position vector of a particle is the displacement. Position vector is the representation of what? A particle with respect to what? Origin, with respect to a frame of reference. Understanding me? Here we have to find out the displacement here by using this. If you watch it keenly, you will observe that we have the initial position, it is, and it is the final position of the particle. Okay, initial position, okay, is I, and position vector OP1, I said it is equal to R1 bar. Okay, it is the initial position vector and OP bar 2 is equal to R2 bar. It is final position vector. Okay, and P1 P2 is equal to what? Delta R bar is equal to change in position vector. Understanding me? OP1, that is equal to R1, is the initial position of the particle with respect to the origin or observer, and OP2 is the position of the particle with respect to the second, and delta R bar is change in position of vector. Now recall back your memories about vector algebra. While learning about the vector algebra, you have learned the triangular law of vector addition, isn't it? Okay, triangular law of vector addition is a very important one to understand the vectors in a proper way. Either it is the addition of the vectors or the subtraction of vectors. You need to know, you need to understand what is the triangular law of vector addition. It is very simple. If two sides, okay, of the triangle are shown, or two vectors are shown as the two sides of a triangle in a order, then the closing side of the triangle is represented by the resultant vector in opposite actor. Okay, maybe it is somewhat difficult to understand. For example, you say it is the vector 1, getting me? Say it is P bar and we have Q bar. Okay, these two triangles, these two positions P and Q bar are shown in that way. I am closing this side by means of a straight line. Now it became a triangle, isn't it? See, here if we add these two, okay, it could be the resultant R bar. Here P bar plus Q bar is equal to R bar. See this, these two P and Q are in a order. That means they are in anti-clockwise direction. The closing side of the triangle is in clockwise direction. Understanding me? The triangular law of vector addition tells us that if the two vectors are represented as the two sides of the triangle in a order, here the two vectors P and Q represents the two sides of the triangle in a order. Okay, the resultant of these two are represented by what? The closing side of the triangle in opposite order. The same thing is happening here. See this? I am redrawing the same diagram here. Okay. I said it is P1 and I located a point here, P2. Okay. And I said it is R1 bar, it is origin, and it is R2 bar. Getting me what I am explaining? And I joined the 2 points. It is. Okay. See, these are the vectors. Now compare with this diagram. R2 bar, and it is shown as delta R. Okay. Here I am adding R1 bar plus delta R. See this? These two are in clockwise and this resultant is anti-clockwise. Getting me? That is, I can write R1 bar plus delta R bar is equal to R2 bar, or delta R is equal to R2 bar minus R1 bar. Getting me? Delta R is equal to R2 bar minus R1 bar. Here I am locating the position vectors x1, x2, comma y2 and z2. Getting me? Understanding? Okay. Here in this way you can represent but the position vector delta R is equal to R2 minus R1. Now watch it carefully. I am writing R1 with respect to the vector notations. These are the unit vectors k cap along the z axis, isn't it? R1 bar can be written as x1 I cap plus y1 j cap plus z1 k cap. Similarly, R2 bar is equal to x2 I cap plus y2 j cap plus z2 k cap, isn't it? We have to take the difference of this, that is delta R bar can be written as R2 bar minus R1 bar, x2 I cap plus y2 j cap plus z2 k cap minus x1 I cap plus y1 j cap plus z1 k cap. Getting me? Here we are writing the terms which are having I x2 minus x1 into I cap plus y2 minus y1 into j cap plus z2 minus z1 into k cap. Okay, this position vector we call it as the displacement. It is the displacement of the position vector, and we need to find the magnitude. It is simple. Delta R, the magnitude of delta R, watch it carefully, under root of quotient of x2 minus x1, that is x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Okay, here it is the magnitude. If you write In the mod, it is known as the magnitude of the vector. The vector is what? Delta r. Delta r is displacement here. I hope you understood. Okay, you understood what is the displacement. Here, this displacement is all about the motion of the particle in space. That means three-dimensionally we got the displacement. And what about the displacement along a single axis or in a plane? It can be understandable very easily by using the same concept here. Okay. Here, one-dimensional motion means what? The change in position of the vector should happen in one dimension. That means along the one axis only. Okay. And finally, you have the relation delta r is equal to what? x2 minus x1 into I cap plus y2 minus y1 into j cap plus z2 minus z1 into k cap. Okay. Here, change in position of the particle. Say it is x1 and it is x2. Here the change in position can be had as x2 minus x1. It is x2, isn't it? Say it is the p2 and it is a position p1. Okay, and it is x1. Then delta x is equal to x2 minus x1. Okay, x2 minus x1 with respect to the unit vector I cap. That means if you eliminate these two, it will be what? One-dimensional displacement along 1D. Okay. Then what about the 2D? The same thing we are doing. Okay. The same delta r is equal to x2 minus x1 into I cap plus y2 minus y1 into j cap. It is for delta r displacement along two dimensions. That is the two-dimensional motion, and obviously it is the three-dimensional. Then you know the magnitudes of that. Here the magnitude delta x, that is modulus of delta x, is equal to under root of x2 minus x1 whole square. In this case, the displacement, magnitude of the displacement is under root of x2 minus x1 whole square plus y2 minus y1 whole square. Okay, it is all about the position vector. In this way, you can find out the displacement of the particle along x-axis and y-axis and as well as the z-axis. And we name them as, if the displacement position vector is taken along one of the coordinates, the position of the particle is changing only along one coordinate. We call it as the one-dimensional motion. If it is changing along the two coordinates, we call it as a two-dimensional. And obviously in three dimensions, that means what? In space, we call it as the three-dimensional motion. If the coordinates, that means the position of the particle, changes along one coordinate, we call it as the one-dimensional. In a plane, two-dimensional, or in space we call it as the three-dimensional. I hope you are understanding what I am explaining till now. Here we talk about the displacement right now, but we have to know about the distance. Distance is the actual length between the two positions of the particles, irrespective of the direction. Okay, irrespective of the direction, it is the actual length. If you watch it carefully, these two positions, the straight one and so on. Distance, in ideal class I said distance is always greater than displacement, and sometimes distance is equal to displacement. it could happen if and only the particle is moving along a straight line. Okay, we know about what is the displacement. Displacement is change in position vector of the particle, or simply we can say the shortest measured length between the 2 points. And distance, the actual length measured between the 2 points, is the distance. If it is the physical quantity, it must have the units, isn't it? As you know that distance and displacement both are the lengths. You know that the length is measured as meter in SIRM case, and centimeter in CJ system, and foot in FPS system. Obviously, the dimensional formula is m0 L1 d0. It indicates that the displacement doesn't depend upon the mass and as well as the time. I hope you understood this class. In next session, we are going to do some problems which are related to displacement and distance. We are going to learn about the problems in one-dimensional motion. I hope you followed the class. If you have any doubts regarding any topic, or if you are feeling any difficulty in any, please put a message. Before that, subscribe my channel and don't forget to watch it regularly. If you are subscribed, what's that? Whenever I posted a new video, you will get the notifications. With that, you can understand the things in a right way. Thank you for watching the video. I'm Ahmed Ali.